You're good. You're good. It's 30 minutes.
30 minutes.
You're all set.
Okay, so I don't have an elaborately prepared presentation. I just thought I would show you some things and tell you a few things. Sorry, can you hear me now? Yeah. So I guess perhaps there's a theme here. If you have a crazy idea and you pursue it for 3 years, you get up in front of BayHac and give a status report. So the company is called Pingwell. This is our new app. It was released in March, and it's called Grocery Exchange. My partner, who I met up with about a year and a half ago, had an app called Grocery Gadget, which is still out in the marketplace. We both started from different ends of the problem and ended up with the same crazy idea. My idea was to gather all the grocery prices and share them among consumers. And we did very little case study, and we realized it would save people billions and billions of dollars. In the middle of the global financial crisis, that seemed like a very good idea, and I think it's still a good idea. Grocery stores do not share grocery prices, and there's just too much data out there. It's just too hard to find out what the price of your basket really will be. People kind of sort of know what they're doing, but they don't know in any great detail, and they never do the calculations. And stores take great advantage of this. There's people in the valley, they're making hundreds of millions of dollars consulting with stores of all kinds on how to do price discrimination, all kinds of pricing strategies that really are unsustainable if everybody has the information. So our thesis is that mobile and computer vision can help us easily gather the information. My partner started with the idea of building grocery shopping list apps, and he added more and more features. He had the first grocery shopping list app, I think, in the App Store about a month after the App Store opened, and he just continually improved it and learned all about what users of grocery shopping list apps want. One day, he added a feature for some users to type in grocery prices just for their own use, and he noticed that tens of thousands of his users were typing in prices. So he thought, well, this is a feature that everybody wants. So one day we stumbled upon each other and merged forces. And Grocery Exchange is rebuilt from the ground up and represents a synthesis of these ideas. Let me see if I can do the tour here. Here we go. So I won't take too much. I have enough demo risk in this presentation. I'll just give you the slides for this. So it's a grocery shopping list app. You can see we have a product database, we have a user database, we have a store database, we have a price database, and we have all kinds of fancy features I won't show you, but it lets you organize your list and keep track of it and shop with it. And if there are prices in there, and we're just getting started, you'll be able to compare prices and see where the best deal is. And the way you do that, I haven't mentioned Haskell yet, have I? The way you do that is by shooting shelf labels. And these pictures get sent up to the cloud. I'll show you some of them in a second. And we process them, and that's when the Haskell comes in. And I'll skip these other pieces here. But basically, once we have all the data, we can do a lot for the user. So I want to talk about how we use Haskell to extract data from the wild. So let me show you some data from the wild. Here are some shelf labels that came in the other day from Texas. Okay? So, a little bit like Doxa, though, the data's wilder. And the formats are non-standard. This person's actually doing a pretty good job, although sometimes they mess up. So, how do you get the data from here? Well, you could say, oh, it's just OCR. Well, it is and it isn't. It's OCR with a lot of, well, let's just put it this way. Eventually I realized that this is a kind of a parsing problem from the language of pixels to a target language, which essentially represents a kind of a database record of what a shelf label, canonical shelf label might look like. And when you're parsing data like this, ultimately I realized that failure is a very good option. So that's one theme I could say that I've picked up along the way here. That when you're dealing with data from the wild that's as noisy as this, sometimes it's better just to fail and move on.
Why are the pictures pulsating?
Oh, it's a very short video clip. So we've, I guess, instead of taking still pictures, we take a very short video clip, and it gives us more bites at the apple. Okay, so that's the data we're dealing with. When we first conceived of the project, we ended up connecting with some Haskell people. In particular, I want to give a shout out to Alberto, who's not here. Alberto Ruiz, who's probably well known to the crowd from his H-Matrix library. A lot of people use that. He also has another library. He's a computer vision academic in Spain, and he has a library called Easy Vision. It's not on Haskell, but it is, I'm sorry, it's not on Hackage, thank you. It is, and it's rather hard to install, I have to say, but once you get it installed, it does work, and it essentially presents a stream, a video clip like that as a stream of images, and you can do all sorts of things with that, including, well, I'll give you, better to show you than tell you, I think. So one of the things we do is we have a processor, and it doesn't require any windows, but when we have problems or we want to improve it, we can turn some windows on. So here I'm asking, in this command line, I'm asking for the windows to be turned on, and I'm going to throw up a very basic set of windows. These are just an option given on the command line. And then it uses OpenGL GLUT for a windowing system, which has its quirks, but it is very effective for lab bench type work like we're doing here. I don't know, can people see that okay? There's going to be some windows popping up here, and what's happening? Here we go. Okay, so it looks like a bit of a mess here. And after you stare at it long enough, you get yourself stop the processing. Actually, let me go. Okay, so frame by frame we're processing, and the way this works is a bunch of detections are run. So up in the upper right, we have contour detection, detects many contours that are useless, some of which are useful, and you have to figure out which ones are which. We also have barcode detection. That's actually pretty common. Lots of apps have barcode detection. Ours is customized because there are lots of barcodes out there that the open source stuff doesn't track, so we added to that. The system Easy Vision has been augmented with some detections that are, some of which are written in native Haskell, and some of which are really wrapped libraries. So we've wrapped some OCR libraries. We use those for various purposes. We have custom OCR. We have barcode detection. All these things feed in to create essentially a set of detections of different types, and we use that as the basis of the parsing algorithm. It's sort of a parsing algorithm, much like you would use for a computer language, except it's 2D parsing. So in this particular label, this is actually one I was working on today. It's got reversed letters, and really very few frames are useful. I'll try and wait till a good one comes along. There we go. So that, to me, is a very good result right there. It looks like a mess, but I can tell that what's happened is now we know exactly what this product is, and we know exactly what the price is. And we can send that off to the database and share it with other users. Okay, so that's kind of what we built. There's lots of code behind this. I can show you a little bit of it right now. So the way I built this, this particular part of the pipeline was I read every parsing library that Haskell was in Hackage, and eventually a pattern kind of sunk in my brain, and I realized that my problem was similar to a parsing problem, although I don't think the people who write in parsing libraries were thinking of images at the time. Let's see if I can find the code. And the beautiful thing about Haskell is once you have a data structure that somehow works, and this is, I guess, the magic for me. I was a beginner Haskell when I started this project, beginner Haskeller. It took me a long time to understand, how people chose which data structures and why. We ended up figuring out that the state T monad was a very, very useful thing. So I've used this over and over again in building up parsers. it lets me write things functionally, but also when I want to, I can treat it very imperatively if I want to. Sometimes it's just more useful to think that way. Of course, it's all pure functional programming. So I ended up building one of the I'm showing you the most elegant part of my code. It's only maybe 160 lines, but it has all kinds of nice combinators that you would use for a parser type. Our parser type is really just a simple state T monad. And there's some combinators that we built. Well, the state, I guess, is the real twist on what you would do. Instead of having a list of input, we just have a set of detections. And then just the last thing I want to show you in terms of the parser is that when you saw that I was parsing an item that was $1. Okay, so we can write things that recognize dollars. So for example, price PDX recognizes dollars by having a dollar sign next to, well, it ends up marking it as a dollar that's been read, and a dollar that's been read is a dollar sign situated next to a single digit. Okay, and so we have recognizers for those things. Can't show you the whole thing, because but it builds up from levels like that. So I have lots and lots of combinators that look for specific things, and of course they all fail very easily because there's a lot of bad data out there, and I don't want to let that through. So that's in this very quick nutshell how this thing works. That's it.
Have you experienced like grocery store companies trying to intentionally obfuscate, like if they're trying to adapt to your algorithms?
Well, not intentionally to prevent them from being read by shoppers yet. Grocery store companies do a lot of, some of the labels are very complicated. Those were nice ones. They'll have, all kinds of writing on there, and, it takes a lot of reading to figure out what the price really is. And they have club price on there and regular price, so we have to take care of all that. And of course the labels are non-standard, so every label is potentially a custom job, although there are certain patterns that we leverage.
Grocery stores used to quote a lot of the store for just walking around with pen and paper writing down prices.
Sorry, I couldn't hear the question.
Grocery stores don't like comparison and shopping, and before there was mobile apps, people would just walk around with notepads and pens writing down prices, and they get thrown out of the store. Oh, wow.
Well, there is an industry that collects prices, and they have to operate in a gray zone there. Sometimes it's okay, sometimes it's not. I think there's a trend in society for people to be used to people using mobile phones, and also, back in the day, if you took pictures at a rock concert, you were thrown out. Now you have your mobile phone up, and they don't throw out their customers. So that trend is in place, I think.
Okay, if you have more questions for Tim, just go ahead and ask him when the experience reports are done. We have one more, and then we're going to start the classes again, so try to keep us on schedule. So.